Hello, I'm Raymond Wang. You see me in such fine quality chemistry educational videos as what is the connection between entropy and free energy? As well as, is it really that important to have a decrease in entropy in order to bring about order out of chaos? Okay, for this particular video, we're going to be looking at entropy. We're going to look at the total entropy of a reaction. And entropy is represented by delta S. Entropy is representing chaos. And in this case here, what we're going to look at this chemical equation right up here, nickel sulfide, burning it in oxygen, and we end up getting sulfur dioxide and nickel oxide as a result of this. Now the question comes down to is what's going to be happening with the entropy? Is the entropy going to go up or down? Okay, if the entropy is negative, then that means that it's going down. That means there's going to be more order. If the entropy is positive, that means there's going to be more chaos and disorder. So let's take a look at this here. So we have our reaction. Now they do give us the values here, the S values, the entropy values in joules per Kelvin times mole. Okay, and the formula that we have here is delta S is equal to the summation of all the moles times the S of the products minus the summation of all the moles times the S of the reactants. Now they gave all that information to us, so let's go ahead and let's try to figure this one out. Okay, well we're going to need to look at our products. Well, we've got SO2 and NiO. SO2 and NiO, we'll start out with that. Now there's we have the ratio here of 2 SO2 and 2 NiO, so we're going to have to double whatever the S value is here, okay? So that's going to be, let's see, products minus reactants, so it's going to be 248 times 2, that is for the SO2, that's what we're knocking out here, okay? Then we look at the NiO, and the NiO value is 38. So we're going to have to look at, we look at this, so this is our SO2, plus we're going to be looking at our NiO, or NEO, okay, and that is going to have a value of 38 multiplied by 2. So that's what we have here for that. Okay, so that's going to be our products. Okay, let's go ahead. Let's quickly calculate this. So 248 times 2 is 496. I'm going to change the colors on that. So 496 plus 76 equals. Okay, so 496 plus 76, and I get 572. So that's what I have for my summation of all my products, okay? So far I have 572. Now let's look at the other side of the coin. We need to look at our reactants. Well, what are the reactants we have? Okay, we've done this. Now we look at the NiS and the 3O2. Well, the NiS has a value of 53, but it is times 2, so we're going to look at the 2 NiS, so that's going to be 53 multiplied by 2, okay, and that is going to be our NiS, that's the other side of the equation. We're looking at the reactants. Then we're looking, so we cross that out, then we look at the 3O2 here, and notice the O2 according to this value is 205, but there's 3 of them, so that's going to be 3 times 205. And that's going to bring us to 615. Oops. This is for our O2. All right, double checking. Yep, this is our O2. So keep in mind that these are the coefficients. We still need to use the delta S value, the S values that they gave us. So now we have here 106 plus 615. That's going to equal 721. Now this is for our reactants. This is our total delta S value for our reactants. The 572 was the total S value for our products. Okay, now we got to sum it up. Now we need to sum it up. So it says products minus reactants. So what was our product? Our product was, let me double check, 572, because it's kind of the end of the day for me. Okay, so here it is, 572 minus 721, because that is the total delta S. That's our delta S for our product. And here's our delta S for our reactant. Okay? So 572 minus 721, that equals our delta S for this equation is minus 149 joules per Kelvin times mole. That is our final answer, ladies and gentlemen. Negative 149. It's pretty easy once you get used to it. But other than that, ladies and gentlemen, that's it. Now, it's a negative, so that's telling us something. It's telling us that the entropy is actually decreasing. Well, let's take a look here for a moment. If we look at the original equation up here, 2 NiS, that's a solid, and 3O2 as a gas, we get 2 SO2 gas and 2 NiO as a solid. Okay, now you're sitting there thinking, but wait a minute, you still got 4 pieces. You've got solid on both sides. You have a gas on both sides. Ah, correct. But how many moles of all those particles do we have? On this side we have 2 NiS, 3O2. So 2 plus 3 is 5. On this side we have 2 SO2 plus 2 NiO. That's 2 plus 2, that's 4. So what we're looking at here, on the reactant side, we have 5. On the product side, we have 4. Guess what? We have brought order out of the chaos. So there's actually a little bit less entropy as a result of this, even though you still have a solid and gas on both sides. The number of moles, or the number of particles, has decreased. That means your delta S has decreased. You have a little bit more order out of the chaos. Hey, I hope this video helped you guys out. Until then, I'm Raymond Wang. See you the next time.